On July 10, 2025, the Massachusetts Attorney General announced a $2.5 million settlement with Earnest Operations, a student loan refinancing firm whose AI-powered lending models disproportionately harmed Black, Hispanic, and non-citizen borrowers. The core of the complaint was a single model variable, the Cohort Default Rate, that had been encoding decades of systemic inequality into every credit decision the algorithm made. The phrase, "the algorithm decided," is now a regulatory admission of negligence. The Consumer Financial Protection Bureau finalized requirements, Circular 2023-03, updated in 2025, mandating that creditors provide accurate and specific reasons for every adverse action. The era of black box lending AI is over. The architecture required to survive it is not a better wrapper. It is a different category of system entirely. Wrapper architectures, those that route applicant data through a third-party large language model, fail the fiduciary test on three axes simultaneously. First, hallucination. A large language model predicts the next token, not a fact. A model can generate a plausible-sounding denial explanation that has no basis in the applicant's file, a liability recognized in the Air Canada chatbot precedent. Second, bias propagation. Models trained on internet corpora carry the racial and socioeconomic stereotypes embedded in that data into every credit decision. Third, inexplicability. When Navy Federal Credit Union defended a 28-point approval gap between white and black applicants, the defense collapsed. The institution could not explain in specific behavioral terms what the algorithm had done. The Veriprajna deep AI architecture replaces the single wrapper with a four-layer socio-technical system. Layer 1 is the orchestration and abstraction layer, a queue manager that handles provider retry logic, semantic caching, and cost visibility, eliminating the antipattern of blocking server threads on probabilistic LLM calls. Layer 2 is the data integrity layer. Before any data reaches an AI model, it is evaluated across 6 dimensions: accuracy, completeness, consistency, timeliness, relevance, and representativeness. This is the contamination firewall. Dirty data cannot propagate to any downstream model. Layer 3 is the multi-model risk engine, and this is where the architecture earns its defensibility. 3 model classes run in parallel. Deterministic rule engines handle knockout compliance checks, residency thresholds, age requirements, with 100% accuracy and 0 probabilistic variance. Gradient-boosted models, specifically XGBoost and LightGBM, handle structured credit scoring where interpretability is required. Fine-tuned large language models, grounded via retrieval-augmented generation in the applicant's actual documents, handle unstructured entity extraction only, the narrowest safe use of probabilistic AI. Layer 4 is the continuous monitoring and audit vault. 3 signals run simultaneously: model drift detection, comparing incoming data distributions against the training set; bias drift alerts, triggering when the disparate impact ratio falls below 0.8, the 4/5 rule; and hallucination detection, cross-referencing every AI output against source documents in real time. Running above all 4 layers is the fairness engineering stack. Adversarial debiasing trains a secondary model, the adversary, to predict the protected attribute from the primary model's output. The primary model is then optimized to minimize its own prediction error while maximizing the adversary's error. The result is a model that cannot perform better by encoding race. The evidentiary record is not theoretical. The Earnest Operations investigation identified the Cohort Default Rate as a proxy discriminator, a variable statistically correlated with the racial composition of an institution's alumni base, specifically historically black colleges and universities. The model was penalizing applicants for their school's collective historical disadvantage, not their individual creditworthiness. The $2.5 million settlement addressed 4 violation categories: proxy discrimination, automated exclusion via immigration knockout rules, inaccurate adverse action notices, and governance failure from unmonitored human overrides. Navy Federal's case demonstrates the systemic scale. In 2022, the credit union approved 77.1% of white conventional mortgage applicants and 48.5% of black applicants. The 28.6 percentage point gap was the widest of any top 50 mortgage lender in the country. When researchers controlled for more than a dozen variables — income, debt-to-income ratio, property value, neighborhood characteristics — black applicants were still more than twice as likely to be denied as white applicants with statistically identical profiles. In May 2024, a U.S. District Court ruled that disparate impact claims could proceed to discovery. Statistical disparity alone survived the motion to dismiss. The burden then falls on the institution to prove that its process is the least discriminatory alternative available. The $2.5 million paid by Earnest was not a fine for bias. It was the price of architectural failure. No mechanism to identify proxy variables before deployment, no independent model validation, no auditable adverse action explanations, no logging of human overrides. Each of those absences corresponds to a layer that deep AI builds in structurally, and that wrapper technology cannot add as an afterthought. The NIST AI Risk Management Framework 2.0, released in 2025, now requires an AI bill of materials, a full inventory of every data source, model component, and third-party API in the decision chain. SR 11.7 requires conceptual soundness and independent validation. That is now a fiduciary question, not a technical preference. We built this framework because the stakes are now structural. Read the brief. It maps the Earnest case in detail, documents the four-layer architecture against SR 11.7, and walks through the adversarial debiasing pipeline. Approximately 16 minutes.